I just want to show one other tool before we move into running the energy analysis. And this is the ability that you can actually treat the different facades of your conceptual building differently. Now, if we go back under our Analyze tab, Energy Settings, we were setting the glazing ratios, the sill heights for the whole building. But you can actually go into the different facades of the building and customize that in a bit more detail. Now what you've got to do, you've got to use Tab. If you use Tab and hover over a particular facade of the conceptual building so that it's selected now, you can see that it's in blue. If you come over to your properties, we've got under values here, by default that will be set to values by energy settings, so it will be picking up the default values for the whole building. If you change that to by surface, it will allow you to control individual surfaces of that building. Okay, and so for example, this is a north-facing window, so let's put a north-facing facade. Let's knock those windows down to 10%, and let's say we don't need any shading because it's facing north. So we apply that and we've changed our conceptual model. Okay, so it just allows you to have that little bit more control over the individual facades of the building. But as I said in the previous session, don't get confused by thinking this is a detailed building design. It's not. Okay, so don't start going into individual windows and configuring windows. This is still meant to be very much at a conceptual level. But the nice thing about this, the capability there, is that you can just make some adjustments for the different orientations of the facade. Okay, so we've done that. There's our building on the site, and now let's run the analysis. So we go back to our energy analysis, and first thing I should say, you need to sign in. Okay, so the energy analysis is done as a cloud service, so it's done on Autodesk's computers. So at this point you need an internet connection and you need to sign in to your academic or Autodesk account. Okay, go back into your energy and you're now ready to hit the Run Energy Simulation. Now, what I'm going to do, depending on how long it takes, we'll set it running the simulation. It will then start to calculate that simulation on the Autodesk servers. Now, depending on how long that takes, we'll either get to see the results or I'll just look at some pre-recorded results. Okay, so Run Energy Simulation. Let's create a new project and let's call it option B. Okay. So I'm just going to shut that window. Okay, now, I didn't watch what it was doing there, but it should now have sent our building off to the Autodesk server for analysis. And if we go here under Results and Compare, it will open it's a web browser, and yeah, under this web service, this web interface, if I just minimize some of these, this is where Autodesk will put all of your simulations that you've run. And if you can just see the one that we just created here, it's processing. And it's 98% complete. So if we just wait a second, it will actually finish there, I should think. So the good thing is it's not taking up your own processing power. It's doing it on Autodesk's servers now. Okay. And it also means you can send multiple operations at the same time, and it won't slow down your machine at all. So that's at 98%. So tell you what, while that's doing that, let's send off another simulation. So let's go to our option D. Okay. See, I just got a pop-up here in the bottom window. That was just telling us that that simulation is finished. So here's our option D. I'm just going to change our design options to option D. Okay. I won't bother changing any of the settings, but let's just send that for analysis as well. So if we go back to the analysis, run energy simulation. Okay. And let's call that option D. I mean, you would be, I'm just doing this quickly, but the more information you can use in these names, then the more helpful that will be in terms of you understanding what you've sent for simulation. So that's just packaging up the energy model to send it over to Autodesk. Just give that a second. Okay, so that's gone. If I go back to my results and compare, I would expect, yeah, there it is. So option D is now busy simulating. Okay. We'll just go back into Revit. So what we've done there, we've sent off option D and option B, which are two different shape, two different size buildings. Okay, sorry, it's not responding at the moment. Okay, so we've sent off B and D, which are obviously these very different shaped buildings. So we're going to have the ability to compare those two options. What you could then also do is potentially within the same option, we could change some of our settings. So if we go back in, for example, and we change our target percentage glazing to 60% for option D. Let's give it a second. All our windows will get bigger. Okay. Windows have got bigger. And should hit save at that point, but we'll just go with it. Let's send that for simulation as well. And this is where you need to give it a name that will be meaningful. Okay. If you don't label these carefully, you end up with a whole load of simulations and you're not quite sure what you've got. So I'm going to call this option B 60% glazed. Okay. That will go off now to Autodesk. So I think what is what is very powerful, within 5 minutes there, I've sent off 3 different buildings for energy analysis. Now, if you remember, a few weeks ago I made the comparison with, in practice, sending off information to the building engineers for analysis, and it would take about 2 weeks to go, come back, make a change, 2 weeks. In 5 minutes, I've sent off 3 simulations. Okay? And that one's still calculating, but let's go and have a look at the first one we did, which was option B. And so what you get is, you get a report. You get an analysis report. And this is the default format for that report. In the top right, you've got Project Salon up here. Now, this is a beta software which allows you to customize the graphic interface. I'm not going to cover that, okay? I think the interface that we've got here is adequate, but feel free to play around with that. You've also got this beta energy cost range, but again, I don't find it all that useful, okay? It's a more sort of, what you can do is you can change the settings in here, and it will immediately recalculate the cost of energy, but I think we'll just leave that for now. We'll go back into our results. So, for each of your simulations, this is the information you get. It takes your screen from Revit, and it positions that at the top of the report. So that's quite helpful, because you can see what you've got. And then you get a summary about the building. So outdoor air temperature, floor area of the building, exterior wall, people, 157 people, the exterior window ratio. You've got some fuel costs here, which do unfortunately come through in dollars. Don't think you can change that. And then we've got our energy use intensity. That we talked about that in the other session. So you've got electricity usage, 111 kilowatt hours per square meter per year. Fuel, and unfortunately they give this in megajoules, so you have to convert it. So we've got the 2 most important parameters right there at the top of the results. We've then got a life cycle cost. So we're looking at 30-year life cycle. How much energy do we use over 30 years? Renewable energy potential. So what we're saying here is, if you were to put photovoltaics on the roof, this is how much energy you could generate per year. If you were to have a small wind turbine, this is how much energy that could generate per year. Carbon emissions. Here's our carbon emissions in terms of energy. Electricity in pink, fuel in the orange. Here's our net CO2. And the purple is, if you were to install those renewables, such as photovoltaics, how much energy could those create? And then if you subtract that, you get your net CO2. So it's not only giving you analysis of the design as you have it, it's giving you potentials if you incorporated some renewable energy. Annual energy use cost, breaking it down into electricity and fuel. Then it's telling you what percentage of that energy is used in heating and ventilation, air conditioning, and what percentage is used as domestic hot water. Your electricity breakdown, heating, ventilation, air conditioning, lighting, miscellaneous equipment. You have a detailed monthly heating load across the year. Okay? And as you kind of expect in the UK, we use more energy in winter than we do in summer. And you also get the detailed analysis of where are those energy flows coming from? So in terms of energy in, window solar is the orange, light fixtures, equipment, the occupants in the yellow. So all of these factors above the zero are creating heat in your building, and then everything below that is where you're losing heat, through the windows, through the walls, through the roof. So there's some very detailed analysis there. You have monthly cooling loads, and what the simulation is doing, it is assuming that there will be cooling through the windows, there will be cooling through some ventilation, and it's giving you the breakdown of all of that here. Monthly fuel consumption, monthly electricity consumption, peak demand, and then at the bottom of the report it simply is giving you some climate data from the site. Okay, so a lot of information in that report. If you click on any of the graphs, it will make it a larger image, and if you click on it again, it will put it back again. Okay. If you go under your settings here, you can customize the outputs that you want to see in that report. So any of these you could switch off. Okay. If you you can obviously print at the top here, export. We'll export this report as a PDF, which is very useful. Now the other useful thing that you can do is you can compare. So now that our 3 building simulations have finished, if I just select them all, which was that one, and it was that one. So if I select these 3 different options, just by pressing Control and click there, and I go up to the compare, it will now put these 3 comparisons side by side into a report. And this, I think, becomes very powerful, because as we scroll down, we can immediately look at the comparisons between the different buildings. So for example, this building here, energy use intensity 1319 megajoules per square meter per year. This version 1031. This version 823. So we're immediately getting some very useful feedback on our designs. And as I've said previously, at this point we would be probably less concerned with the actual figures, but we're more concerned with the comparison. And if we scroll down, again we can compare the different versions. So for example, our first option here, the energy generation potential is much lower, so the net CO2 is much higher. Here we have more potential, and we can look at the breakdown for all of these buildings. Okay. And again, if you export, you can export this as a PDF. Okay. Now the thing that I think is very useful for yourselves is, because, as I hope this is demonstrated, because this is such a quick process, once you have the conceptual building and once you have the site, it allows you to be running this simulation again and again in an iterative workflow. So obviously when you're designing a building, there are other factors than just energy. And so once you got to the point where you were happy about a certain kind of configuration of the building, you might then run the simulation again. You might change the window size, you might change the shading, and again start to look in more detail at a conceptual level. Okay. Right. Any questions on the conceptual level at this point? Okay. Thing to do is go away and have a try. Okay. I'll give you this Revit file. Go away and have a play with it. We're going to move quite quickly now into, save that, into performing the same kind of analysis, but this time using a building model. So I'm going to open a different file now. This is the same site, but this time, rather than having the conceptual building, we will actually have a detailed Revit model of the building. And again, this is the file that will be provided to you for the assignment. Okay. So there's our site, there's the Arts Tower, and this is the proposed building for the Arts Tower forecourt. Okay, and as you can see, this time this is not a conceptual building, this is a fully modelled building. And if we look at some of the floor plans, this is a fully architectural modelled building. Okay, so this building is now modelled with accurate construction types. It has wall types, it has window types, it has doors, it has floors, stairs. So it's a kind of building that you've, in an office environment, the design has developed and you've got a reasonable level of information now such that you've modelled the building. I've just clicked on a section there, so you have you cut a section through it. Just zoom in a bit. The wall is modelled, so this wall is modelled as a cavity wall with insulation. Okay, so we've moved on now into a more kind of detailed level building. Okay, so as I say, this is the model that you'll be given, and at this stage in the case study, in the scenario, it's assumed you've kind of moved beyond the conceptual level and you've now been given this more detailed architectural model to, again, start to test and start to simulate. Now, the process in Revit for the energy simulation is actually very similar to the process that we just looked at. And I think one thing that is important to understand is the simulation in Revit, it is not a sort of detailed room-by-room temperature simulation. Okay, it's more looking at the overall energy performance of this building. And every year, students ask me, how do I simulate the temperature range in one particular room in that building? Now, it's not the software for that. Okay, for that you would need to use, you can do that in Ecotech, you can do that in IES, but for the purposes of this module, we're not getting into that level of detail of looking at the actual temperatures within the rooms. We're looking at the overall performance of a building. Okay, so We're now going to run the simulation. If we go into the Analyze tab, as before, and this time, importantly, you need to be in the Use Building Element mode. Okay? And that is essential because that will tell Revit to run the analysis on the building rather than running the analysis on the conceptual masses. What Revit will now do is any mass which Revit finds in the model, it will use as a shading surface. So it will take the Arts Tower, for example, which I've highlighted there. It will say, okay, I'm not analysing the performance of that building, but I will consider the effect of the shading effect of that mass on your actual building performance. Okay, so that's really important that you select the Use Building Element mode. Okay, and then we've got our energy settings, which is exactly the same dialog. And this time we will actually start to look at the detailed model settings. So, export category. Generally, you leave that on rooms. If you change that to spaces, that is then allowing you to go into each individual space and start to define the energy settings, the HVAC system for any room in that building. And I think that's really far too complex for what we need. Okay, export complexity. You can export it as simple, complex, with or without shading surfaces. So you have different levels of precision and accuracy for the simulation. Include thermal properties. Now, because this building has been modelled correctly, we will include the thermal properties, and then what the software will do is it will take the thermal properties of all the elements of that building. So if we don't include that, it will just use a sort of generic set of construction types as we did in the previous session. But since we've modelled all of those walls and roofs with insulation, we can use thermal properties. Project phase, we only have new construction, so we just leave that alone. And again, the sliver space tolerance setting is about this sort of accuracy. Now, what the sliver space tolerance is doing is you're telling Revit any gaps which are smaller than about 300 millimeters, just ignore them. Okay. Again, if you set that too fine, what Revit will do is if you have any gaps in your model where walls don't quite meet each other or don't quite meet a floor, Revit will try and continue the room beyond that gap. So generally just leave that alone at about 300 millimeters. Okay. Then under our energy model settings, you see most of these settings are now grayed out. And that's because we're not setting a conceptual glazing percentage because we've actually got windows now. Okay, so it's not using those settings, it's using your actual building. Building operation schedule as before, HVAC system as before, outdoor air information as before. Okay, so all those settings are now okay. You're ready to export. Now, what I need to explain to you now is you're ready to hit the run energy simulation. There are limitations to the simulation engine. So Revit is using DO2. Now, what you do find is if your model is too complex, the export will fail. Okay. Now, ideally, the easiest way forward is to run the export through Revit as we did before. If the model is too complex, you have to go about it in a slightly different way. And you have to export GBXML from Revit, and you have to import GBXML into Green Building Studio. Now, I'm not going to go through that today because hopefully you never need to use that, but I've got a video that I've produced that shows you how to do that, which I'll put onto Mole. And I'm afraid it's just one of those limitations of the software at the moment. What actually happens is when DO2 receives more than a certain number of faces, it can't calculate it. I've forgotten what the actual figure is, but it's just a limit in the software at the moment. Okay, so I tested this last night and it worked, so it should just work as normal. If it doesn't, you would have to use the other option. Okay, let's just hit Run Energy Simulation, and so it's saying that you need to create the energy analytical model. Okay, go ahead, and then we'll just wait a minute. And it's doing the same. It's doing the same as before. It's packaging up the model to send it off to Autodesk. Normally takes 2 or 3 minutes to do it. Okay. So, okay, just listen please. So it gives you this little warning, and it's just saying Revit model content and complexity varies widely. We recommend that you check the wholeness of the energy analytical model. So it's just a sort of a disclaimer saying, you know, Autodesk are providing you with results, but you know, it's up to you to check them. Okay. So let's give this a name. I've already used that name, so let's just call it option E. Okay. So it's sending the energy inputs across. Okay, so while it's doing that, let's just go and have a look at the results. I sent it yesterday, so I've actually already got the results back for it. All right, there it is. So it's coming through. See, it's busy calculating. I think it's a little bit slower when it's doing the full building simulation. Anyway, let's just have a look at the results. The results you get are the same as the conceptual level. Okay, so it gives you the results in exactly the same way. So it will look the same, but the difference now is that because it's it's producing those results from a much more detailed building, you'd expect the level of accuracy to be much higher. Okay? And it's interesting, sometimes when you compare the conceptual level analysis with the detailed building level analysis, often they're fairly consistent. The sort of accuracy you're getting, is quite reasonable. Okay, so that's coming through now. As I say, I did test it last night, so it should work. We did have some problems last year, whereby when we were sending this building through for simulation on the site, we were getting that problem where the model was too complex and the import was failing. Okay. Now, as I say, I'm not going to talk through the other interface, but while that's calculating, I'll just explain a few things about that. Now, we are now accessing this information in Green Building Studio. What we're seeing at the moment is the Revit interface to Green Building Studio. So, and it actually looks quite different. So what Autodesk are doing is they're saying, well, you have a Revit interface and you have a Green Building Studio web-based interface. They're both taking the same model information, but they're presenting it back to you in a slightly different format. Now, the Green Building Studio interface offers you a few things extra that you don't have through the Revit interface. So, for example, it does offer you water consumption, water collection parameters, which can be useful. But the disadvantage is you have to go through this export-import process, which is sort of not the ethos of this course. So what I'm generally doing is encouraging you to stick to the Revit interface, which is this interface. Okay, go and watch the Green Building Studio video that I produced. Have a look at it, and if you think that offers you something better, by all means use it. But for the purposes of your assignment, perfectly fine to just use this interface, the Revit interface. Okay, so that analysis, it's telling me, has finished. So there it is, option E. So the results have come through. It did work. I think DOE 2 has improved slightly. I think last year we were on, you see here, we're using version 2.2. I think last year we were on 2.1 and it was crashing a lot more. But, that's clearly worked, which is great. So there's our analysis for that detailed level building. And I think, again, this is where we're getting into something really quite powerful here as a designer, whereby I could go into my building here, just zoom in there, I could go in, don't save, I can select that window and I could change, for example, its sill height over here. Okay, so I can change that window. I could drag that window about. I could move it. And it's a bit small to see, but if I just zoom in on the 3D, oops. The beauty of a 3D model is, of course, when I move that window in plan, it's actually being moved in 3D. So there's that window that I've just moved. Okay, the shading device, I could delete that shading device. So I can modify my building like that. And then all I need to do is go back up, run the energy simulation. 5 minutes later, you would have another set of results incorporating that change. Okay, I mean, I'm not suggesting you would keep running it every time you move a window. That would, take you forever. But you could have that design. You could say, for example, okay, let's see what happens if we substantially change that glazing there. Let's change that. Let's make it much shorter. Let's put a huge shading device on it. Rerun the energy simulation. You could remodel your roof. You could put skylights in your roof. Rerun the simulation and keep looking to see what the change is. And the sort of simplest one to look for is the total energy use intensity. That's your sort of basic energy consumption, and also your net CO2. Okay, down here. So, I think this is where, in the last few years, we've made huge improvements in the software. And this is where the power of, as I keep calling it, integrated simulation comes into its own. That you as a designer, you can be in control of that model, you can make design changes, and you can simulate the impact in terms of energy. Okay? In the sessions next week, I believe, we'll then look at how you can start to also simulate the impact on daylighting and illuminance. Okay, so we'll move on to that next session. Right, so I'll just undo my changes there. Okay, so just to summarize, on mole, you will have the conceptual model that I used in the session before, and you'll have this more detailed model. And when you reread your assignment brief, it talks about how you need to use both of them. Okay? Also, reread that brief. It's very clear about saying that you've been given an unfinished site model, which again is on mole. You need to complete it. So the site model that I've provided you with has got some of the buildings, but it's not got all of them. So you need to do a bit of work on that. Okay? And then, in terms of the energy analysis, what you're asked to do in the assignment is kind of what we were doing this morning. You're comparing different design options, and you're commenting on the results. And then at a more detailed building level, what we're asking you to do is actually take this building and modify it, and look at the impact. Now, I know we're not expecting you to be experts at Revit, but you can easily play around with selecting windows, delete windows, move windows, and start to look at the results. Okay? And if you look at some of the example reports from last year, you can see the kind of work people did, where they were taking this building, making modifications to it. All right? Any questions on that session? Again, we've covered quite a lot. You'll have to re-watch the videos.